Hey everyone, this week we're going to finish working on Chapter 5 in the textbook. Our task today is going to be to talk about what are called causal arguments, arguments that are sort of giving us causal explanations about why particular events are taking place. So that will finish up Chapter 5. We'll have an exam on Chapter 5 at the end of the week. Let's get going. Alright, so let's begin by defining exactly what we mean by a causal explanation. So we're going to say that a causal explanation gives us the antecedent event that explains why some other event happens. So we're going to call the antecedent event the cause, the result that we're explaining is the effect. So let's do a real quick example. So the tree fell because of a windstorm, or the windstorm caused the tree to fall. In that case, the cause that we're positing is the windstorm. The effect is the falling of the tree. Now, causality is a hugely complicated topic in philosophy. There's not even really good agreement about exactly what it means, what counts as a cause, how it counts as a cause, so we could spend an enormous amount of time, but that's not really our sort of focus in logic. So, for the logical purposes, we're just going to focus on a pretty basic common sense understanding of causality, and we're not going to necessarily worry about all the nuance that perhaps we could be concerned with. Alright, so what's a specific causal argument then? We're going to define a causal argument as an argument that in its conclusion suggests that some sort of hypothetical cause is the best available explanation for why some other event, the effect, takes place. So we need to use this key concept here of the best available explanation. When we're going to be engaged in sort of causal reasoning, we're usually going to have a bunch of sort of what we're going to call causal hypotheses. Possible events that could be the cause, but we're not sure. We don't know for sure, so they're sort of like the candidates that we're running through. The best available explanation is the one of those hypothetical causes that fits the data the best. The one that it's the most rational to believe is indeed the cause based on the evidence we have available to us. Again, this is going to be an inductive probative argument. We could indeed come to discover we were mistaken in our causal judgments as we acquire new evidence, learn more about the situation. But based on the information available to us, our goal is to find the most rational possible conclusion about what the cause seems to be, and we're going to call that the best available explanation. Right? So let's do a quick little example, right? So here's a causal argument. The windstorm was the cause of the tree falling. We can know this because there's a windstorm right before the tree fell, and there doesn't seem to be any evidence of sort of human activity or cutting on the tree, so the best available explanation is that it was the windstorm. Broadly speaking, there are two different kinds of causal claims. There are the kind like we just talked about, what we're going to call particular explanations. This is where we're explaining some particular event in the world with some specific causal event in the world, right? So the tree fell because of the windstorm. In that case, the windstorm is the specific cause of this specific event. But a lot of the time, what you see in causal arguments isn't really dealing in specifics, it's dealing more with generalities. So, for example, if you were to see a claim to the extent that exposure to extreme heat causes third-degree burns, we're not talking about any particular instance of exposure to high heat, and we're not talking about any specific instance of third-degree burns. We're speaking in general, this kind of cause goes with this kind of effect. In these general causal explanations, we're frequently going to actually discover what are called contributory causes rather than sort of direct causes, or sufficient conditions for the event to come about. So what we mean by a contributory cause or a causal factor is something that makes the effect a lot more likely to happen, but doesn't ensure it or guarantee it. And a lot of causal arguments are really describing contributory causes rather than sort of sufficient causes. So let's look at an example of this. So if I was to say smoking causes cancer, this is a general causal explanation, first of all. I'm not talking about any specific instance of cancer that I'm trying to explain. But it also isn't always true, right? There are some people who indeed smoke and won't get lung cancer. But smoking dramatically increases the likelihood of cancer occurring. And so for that reason, it's what we're calling a contributory cause or a causal factor, something that makes the effect way more likely to happen. Alright, so those distinctions are all important and relevant, but they're not really going to affect how we evaluate causal arguments. We're going to use the same basic procedure to analyze sort of causal arguments that are dealing with particular causal explanations, general explanations, or ones that are describing contributory causes. We'll have the same basic procedure. The only thing relevant in analyzing a causal argument is the explanation that's being posited in the conclusion really the best available explanation? And if it is really the best available explanation, you'll have a good causal argument. If not, you won't. we have a list of 5 criteria that we're going to use to sort of determine whether or not something is the best available explanation. And this list sort of is going to go in order. So you'll sort of want to do the first step, then the second step, then the third step. Basically, each step of the sort of process is going to allow us to cross off some of the causal hypotheses until at the end, we should only have one left, and that should be the best available explanation. All right, so the first of our criteria for determining the best available explanation is that the cause and effect that are posited in the conclusion of the argument should indeed be things that are correlated. What we mean by correlation is pretty straightforward. 2 events are correlated if they occur together. So it's a pretty straightforward notion. We have positive correlation. That's where the 2 events, when one of the events is present, the other of the events also is present. We've also got the idea of negative correlation. That's where one of the events is absent, and then the other one also is absent. And ideally, you'll have both positive and negative correlation together. You'll have both of them working together. When we're dealing with issues of contributory causes or causal arguments looking at contributory causes, this doesn't have to be all or nothing. You can have sort of degrees of correlation. So you can say, for example, that 95% of the time when someone is a smoker, they're 95% more likely to get lung cancer. That would be a strong correlation, in that case a positive correlation, between those 2 events. Note, however, correlation is not the same thing as causation. 2 events can be correlated without being causally related. So here would be just a sort of a simple example, right? Suppose that there are 2 people watching a movie. Say it's a scary movie, they're watching a horror movie of some sort, and at roughly the same time, both of them jump backwards. So those 2 events are correlated, right? They happen together. Yeah, we wouldn't really want to say that one jumping backwards causes the other to jump backwards. We'd say that both of them jump backwards because of the scary movie. The movie is sort of the causal explanation, right? Maybe there's a scary scene or something of why the 2 people jump back, even though they're correlated events. Our second causal criteria is that the cause should occur prior to the effect. I think it is a pretty straightforward sort of sense of this. I guess there's some weird quantum mechanics stuff that maybe is contrary to this, but we're just dealing with a pretty ordinary notion of causality where, yeah, the cause occurs before the effect. The cause is prior, that explains why the effect occurs. So let's do a real quick example. We'll use this example going forward the rest of the time. So let's say all of the lights go out in my basement while I'm working out. Say that event takes place, and I want to know why it happened. Well, okay, I'm not going to posit that the cause of the lights going out is something that's going to happen later, right? So say later later on in the evening I'm going to eat a sandwich. Me eating that sandwich couldn't possibly have caused the lights to go out. I would have had to have eaten that sandwich first for it to even be a candidate, right? Because it occurs after the effect that I'm trying to explain, it's no longer even a compelling causal candidate, right? And so it can be gotten rid of for that reason. Again, we need to be careful here, though. Just because one event comes before another event, that does not mean that those 2 things are causally related. A lot of superstitions kind of have this quality, right? Like, oh, I saw a shooting star last night, and then I found $20. I guess the shooting star must have been lucky or something, right? Like, no, I mean, it's probably just a coincidence that those things are sort of connected, right? It's the post hoc fallacy is what we're going to call any argument that assumes that just because one thing comes after another thing, that the first caused the second. So it is a sort of a condition that has to be met, but you can't just stop after the second condition. If the argument stops after the second one, it's committing what we're going to call the post hoc fallacy. All right, so far we've allowed some perhaps kind of silly things in. Like our conditions so far are sort of the bare basic minimums for one event to cause another event. And so we're sort of, some silly candidates are left. So say, for example, if I'm trying to explain why the lights went out in my basement, maybe, if I ate a sandwich before working out, we've still left that open as a possible cause. We probably don't want to do that, right? That doesn't seem like the right kind of thing to explain why the lights went out. We're going to call this, we rely upon in causal judgments a pre-existing causal framework. We have some rough idea of what kind of things cause what kind of things. Right? It's why you also probably, your first thought wouldn't be, ooh, it was a ghost. Right? The ghost is why the lights turned out in my basement. Right? I mean, it maybe I posit the ghost is coming before the lights went out. Maybe I posit a correlation, but we just don't think of that as the kind of thing that causes lights to come out. And that's because there's a pre-existing framework that sort of establishes what kinds of explanations for why lights go out, maybe mechanical explanations or electrical explanations. That's the kind of explanation you'd look for. it's actually really hard to justify exactly where these pre-established causal frameworks are coming from. You can sort of maybe loosely say science, but in a lot of cases, science seems to be relying upon them too. We're not going to worry about cases where someone is trying to, in their argument, challenge a pre-existing causal framework. I'm hoping that we'll have some time at the end of the semester to do that. We talk about sort of extraordinary claims, like what would be actually necessary to prove that there really are ghosts and that ghosts cause lights to go out. It's not impossible, but it just isn't, for the sort of normal kind of causal discussion that we're talking about here, it's just not really relevant. We're going to cross out anything that isn't sort of a initially credible explanation for the kind of cause event we're looking at. So in this particular case, right, we're going to look at things like, did the circuit breaker go out? Is there a problem with the electricity? Right, credible causes. And that's our third criteria, should get rid of basically most of the sort of like goofy stuff that we really just don't think is the right kind of thing to be causing this event. So the reason you want to follow these criteria in order is that now that we've gotten the first three taken care of, we've got a pretty solid list, or we should at least have a pretty solid list of credible, plausible causal candidates for why some event happened. We should have basically gotten rid of everything silly through the first three of the criteria. So the fourth criteria now, we only have sort of plausible candidates, right? We only have credible candidates remaining for what could have caused the effect. Now you need to look and see which of these available remaining hypotheses fits the data the best. And if you find one that fits the data better than all of the others, you can indeed stop there. You don't need to keep going on to what we're going to see as the fifth criteria. So let's say, I'm looking at why did the lights go out in my basement, and I sort of go upstairs, I look outside, I see the power seems to be on in the rest of the street. Okay, that sort of suggests that it probably wasn't a power outage. A power outage is a plausible candidate for why the lights might have gone out, but it's not, the data doesn't match it. I would have expected my whole block's power to be out. So maybe I think it's a problem with my circuit breaker, so I go and check the circuit breaker. Nope, circuit breaker's fine too. Again, that explanation doesn't fit the data. If there's only one left after this process, I find one that just fits the data better than all of the others. Say, I found what looks like a light bulb that's burned out, or maybe a lot of light bulbs that have burned out. Then I can stop right there. Our fifth criteria is reserved for cases where there's actually multiple causal explanations that all seem to fit the data kind of equally well. So let's say one possibility is just all of the light bulbs happen to have gone out at the same time in my basement. Not impossible. The other causal explanation, say, that also fits all the data available to me, though, is that maybe there was a power surge and that caused the light bulbs to die. All right, which one should I choose? I've said, they both fit the data equally well. I don't have any sort of reason on the basis of the information available to me to prefer one over the other. The last sort of thing that we're going to rely upon to distinguish between those options that fit the data equally well is what we're going to call Occam's razor. You should always pick the simplest available explanation, but this is the important part, right? This is why it's the last thing you do. The simplest available explanation that indeed fits all the data as well as any other explanation does. So this is sort of you don't start by doing this. This is something you'd only do at the end of an inquiry into a cause. And so, what's more likely, what's more plausible, what's a simpler explanation that all of my light bulbs just happen to have gone out at the same time? That seems pretty unlikely, a lot of steps in that. Or that there was a power surge that caused the light bulbs to blow out or to burn out. That seems more likely. That involves less assumptions, it has less steps, so it satisfies the condition of Occam's razor. It seems to be the simplest available explanation, given all the data available. And again, make sure you only use Occam's razor once you've actually got your list down to the explanations that fit all the data equally well. Sometimes more complicated explanations are preferable if they fit the data better. All right, so we're going to add one other fallacy besides the post hoc fallacy to our list of, plausible fallacies. We're going to have the questionable cause fallacy. So the questionable cause fallacy is any argument that proposes a cause that just doesn't fit the available data, really. We're going to say that commits the questionable cause fallacy. So, if, say, the data just really doesn't support my hypothesis that there is a power outage on my street, but I still posit that as the cause anyway, we're going to say that's committing the questionable cause fallacy. It sort of just fails to fit the data in an adequate way. All right, so that's going to do it for this week in our discussion of Chapter 5 and causal arguments. We'll go through some more of this in class, and then we'll have an exam covering all the Chapter 5 material once we've gone through it. All right, I hope everyone is doing really well. Have a good one. Bye.